Okay, today we're going to learn two gas laws. The first one is called the combined gas law. So you need to get the name, combined gas law, and then go ahead and get down the equation. Okay, so the equation for the combined gas law is P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. And then when you look at this equation, does it look kind of similar to what we've already learned? Okay, so let's look. It's the combined gas law. Why do you think it's called the combined gas law?
Because it's volume and P is combined.
Okay, so I want you to look at this really quick. It's combining the three gas laws we've learned before. So it's combining Boyle's, Charles, and Gay-Lussac. So look up here. So I would get rid of the T1, T2. Do you see how P1, V1 equals P2, V2? Okay. That's Boyle's law. Then let's cover up the P1. So if I stand this way, do you see how it's V1 over T1 is equal to V2 over T2? Okay, that's Charles' law. And then we can do, which one did I just cover up? Yeah, that's Charles. And then if we cover up the V's, it's P1 over T1, P2 over T2, Gay-Lussac's law. Okay. So do you see how this equation is just combining all three of those laws into one now? Okay. So do we already know what P1, V1, and T1 stand for? Okay, we're feeling comfortable with that. Units for pressure and volume don't matter as long as they match. However, what unit does temperature have to be in? Okay, and are we already getting the hang of that? Good. All right, so when do you think you would use the combined gas law? Okay, so it's when all three variables change. So it's when pressure, volume, and temp all change. So last week and the week before, when we learned Boyle's, Charles, and Gay-Lussac's law, all of those had something constant. So either temperature was kept constant, pressure was kept constant, or volume was kept constant. Okay. So now, if all three of those change, we use the combined gas law. Okay, so let's do a practice problem. So the volume of a gas-filled balloon is 30.0 liters at 40 degrees Celsius and 150 kilopascals. What volume will the balloon have at STP? Okay, so first, let's just define STP. Okay. Do you remember STP from our stoich unit? Just barely, we talked about liters. Maybe. Okay, so STP stands for standard temperature and pressure. Okay. And that is always referring to 0 degrees Celsius in 1 atmosphere. Okay. So go ahead and just copy that down. So STP, it's always 0 degrees Celsius, 1 atmosphere.
I thought that was like energy percent.
No.
Oh, that's ATP.
ATP.
STP is what?
It stands for standard temperature and pressure. Okay, so standard temp is 0 degrees Celsius. Standard pressure is 1 atmosphere. Okay, so now we're going to start this problem like all the rest. We're just going to identify those variables. So go through the problem and just start with the first number. Okay, so the first number is 30.0 L. What does L mean? Okay, and that is a unit for, okay, so volume. So V1 is 30.0 liters. Your next number is 40 degrees Celsius. That's a unit for. Okay, so T1 is 40 degrees Celsius. Are you ever going to be in Celsius? Okay, so how do you convert to Kelvin? Okay, so it's 273 plus 40. Okay, so convert right away so you don't forget. So 313 Kelvin. And then that third number is 150 kPa. kPa is a unit for pressure. So P1 is 150. Okay, what are you solving for? Okay, so it says what volume? So we're solving for volume. And then STP is giving you some info. So what's the temperature at STP?
0 degrees Celsius.
Okay, so T2 is 0 Celsius, which is?
273.
And then finally, what's pressure at STP?
Atmosphere.
Okay, so do you see how you're grabbing two pieces of info from STP? That's giving you temp and pressure. The only unit that matters is temp. What unit does temp have to be in? Well, temp has to be in Kelvin. Pressure unit doesn't matter, except they have to match. Okay, so do you all see the problem here? Okay, one is in kilopascals, one's in atmospheres. It doesn't matter if you're in kilopascals or atmospheres, they just both have to be the same. So I recommend you just use the simplest conversion. So 1 atmosphere equals 101.3 kilopascals. So if you look at that, which one's going to be easier to convert? Good. Okay, 1 atmosphere, what does that equal? Okay. Can we convert that one without doing any math? Okay, I would recommend that. So like if you're not sure which one to go to the easiest conversion. Okay. So it doesn't matter if you decided to go to atmospheres, are you going to get the same answer as us? Yes. Okay. Okay, so now you're going to look, what equation do you know that has V1, T1, P1, V2, T2, and P2 in it? Okay, you're going to use that combined gas law. So it's P1, V1, T1 equals P2, V2, T2. Okay, then you're just going to plug your numbers in.
150.
Okay, so we have 150. Let me back up for a second. Before you plug your numbers in, as long as your units look good up here, you can drop your units in the equation part. Okay. So we have 150. V1 is 30, and I'm going to drop the units to keep life simpler. Okay. And then T1 is 313. P2, 101.3. V2 is what we're solving with, so I'm going to use V2. And then T2 is 273. Okay, are you all with me so far? Sorta. Do you have any questions of like where anything is?
What does KPA stand for?
KPA just stands for kilopascal, and it's just a unit of pressure. So it's just one way we measure pressure. Okay. And then are you okay at this part, the equation and plugging in? Okay, here's the good news. If you love algebra, can you start multiplying your denominators to both sides, and can you do algebra? Okay, you can. The good news though, if you don't love algebra or you're not great at algebra, this can also just be one big cross multiplication problem. Okay, so you're going to start with the diagonal where you're not solving for. Okay, so you're going to multiply these three numbers. So everyone take out your calculator. You're going to multiply 150 times 30 times 273. Okay, multiply those three numbers.
1,228,500.
Okay, and you don't even have to clear that. So now you're going to go to the other diagonal. Okay. Take that answer, divide it by 3/13, hit equal, and then divide it by 101.3, hit equal. 38.74. I think that sounds right. We'll round it. Okay, so if you want the easy way to solve this, everyone look up here. You're going to multiply, 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 hit equals, get an answer. Okay, then divide, hit equals, divide, hit equal. Okay, so you all practice. Can you get the right answer? Are you all getting the 38.7? Okay, last step is sig figs. Sig figs should be relatively easy. You just look at your equation. What's the smallest number of sig figs you see in one of these numbers?
3.
2. Okay, this one, 150 just has 2. So what do you round this to? Okay, so this becomes 39. And then how do you know what your unit should be?
Should be the original volume.
Okay, it needs to match the unit for V1. Okay. So it becomes 39 liters. Okay, so far, we've learned how to calculate pressure, volume, or temperature of a gas, right? Okay, but these are all missing something. They're all missing a quantity or like moles. So now we're gonna add on. So how do we start figuring out like the quantity of a gas? This one I just want you to look up. You don't have to write this one down, but I do want you to pay attention up here. So last unit when we did stoichiometry, do you remember just for like one day, we talked about Avogadro's hypothesis where 1 mole of gas took up 22.4 liters? Does this like vaguely sound a little bit familiar? Yeah. Okay, the shortcoming of Avogadro's hypothesis is it only works at STP, okay, which is standard temperature and pressure, or this 1 mole equals 22.4 liters, only applies when it's 0 degrees Celsius and 1 atmosphere. Okay. However, how often are you ever in a setting where it's 0 degrees Celsius and 1 atmosphere? Hardly never, right? So does this work at any other conditions? Okay, so then our 5th gas law we're going to learn is called the ideal gas law. So this is how we can figure out the number of moles when we're not at STP. So any temperature or any pressure. So I want you to write down this equation. Okay, so PV equals nRT. And then you need to write the key. This time units matter for all of them. Okay, so P is pressure. Pressure has to be in atmospheres. Okay. V stands for volume. Volume has to be in liters. N stands for number of moles. Why do you think this one is N instead of M? N stands for number, okay? So just kind of remember that one. N is for number of moles. R is something called the universal gas constant. This number doesn't change, okay? It's always 0.0821. And the unit is a liter times an atmosphere divided by a mole times a Kelvin. And so since R doesn't change, this is why your other units matter. Okay, so since R has liters times atmospheres divided by moles times kelvins, that's why pressure has to be in atmospheres, volume has to be in liters, temp has to be in kelvins. And then finally, T is temp, and temp has to be in kelvins per usual. Okay, we're gonna do 4 practice problems. Each one is a little bit different. We'll either solve for a different variable or we'll practice converting different units, okay? So our first one is, okay, at what temperature will 0.0470 moles of gas fill a 1.20 liter balloon at 0.988 atmospheres of pressure? Okay, so we're gonna start this one like all the rest. Okay, so start by just identifying your variables. So what's the first number given?
0.40.
Okay, and that's a mole. What letter do we use to represent moles? Okay, make sure you write N for number of moles. How many of you are tempted to write M for mole? Okay, don't do M. You're going to be confused because M isn't it's not in a formula. Okay, so do N. So N equals 0.0470 moles. Okay. What's the second number? Okay, 1.20 liters. Liter is a unit for? Okay, so volume is 1.20 liters. Okay. What's the third number you see?
0.
Okay, and it's ATM. What's ATM? Okay, so ATM is telling you to pressure. So 0.988. Okay, and then what are you solving for? Okay, you're solving for temperature. Okay, so far, if you look at the variables you have, if you see N, what equation should you be thinking? Okay, you should be thinking ideal gas law. The word problem's never going to give you R. However, do you always know the value of R? Yes. Yeah, I'll give it to you. R is a constant. It never changes. It's always 0.0821. Okay. And the unit is a liter times an atmosphere divided by a mole times a Kelvin. Okay. Okay, so we know we're going to use the ideal gas law. Before we plug into the equation, check your units. Your units have to match R. Okay, so everyone look up here for just a second. So R is liters times atmospheres divided by moles times kelvins. So you need to make sure, is your volume in liters? Okay. Is your pressure in atmospheres? Is your N in moles? And is your temp in Kelvin? Okay. If they are not matching these units, what would you have to do? You'd have to convert them to match them. Okay. So like once your units match, then we can use the equation. Okay. So what is the equation for the ideal gas law? Ooh, that's a terrible N. Okay, so this time, I would recommend doing algebra with your letters up here before we put numbers in. Okay. So we know we're using PV equals nRT. What variable are we solving for?
Temp.
Okay, so how do we get temp by itself? How do you move nR to this side? What do you have to do?
Multiply.
They're multiplied already, so what's the opposite? Divide. Okay, so temp is equal to PV divided by nR. Okay. So I would recommend doing this step first. Okay, it's easier just to divide a couple letters than it is to deal with numbers. So now that we've rearranged the equation to solve for T, now we can just plug in the numbers. Okay, so pressure is 0.988. And at this point, as long as your units looked good in like your setup, you can drop your units so it's like less confusing down here. V is 1.20 liters. N is 0.0470 moles. And R is 0.0821. All right, so now you're gonna practice typing this in. You can enter it all at once on your calculator. If you're going to do that, do like double parentheses in your numerator and your denominator. Okay, so if you want to enter it in all at once, enter it in exactly how you see it here. So like make sure you have parentheses around the numerator and the denominator. So everyone practice. Can you type this into your calculator and get the correct answer? Does it stink to do all this work and have it set up right and then just get the wrong answer because of order of operations? Okay, so practice. Can you get the correct answer? Okay, what are we getting? Are you getting 307? Okay, last step is sig figs. How many sig figs are like your least amount in your equation? Okay, well, there's always 3, right? They all have 3 in them. So it's 307.2, so it rounds down. Okay, what's your unit for temp? Good. Okay, this time we're going to figure out how many moles of oxygen will occupy a volume of 2.5 liters at 1.2 atmospheres and 25 degrees Celsius. I want you to try this one on your own. Okay, so how far can you get on this one without my help? Okay, let's check in so far. So first, you just have to figure out all your variables. Do you agree with what I have up here? Yeah. Okay, so check your work with mine. Were you at least able to figure out like your pressure, your volume, your temp? Okay, so then what equation are you going to use to solve for moles? Okay, you're going to use the ideal gas law. A lot of you seem to get this step okay. Some of you seem to have just a little bit of trouble from here. Like, where do you go from here? which variable are you solving for? N. So that means we want to get n by itself. So what do you do with RT? Okay, you divide, right? So you divide both sides by RT. So then n equals PV all over RT. Don't skip that step. It's okay to draw this step on paper. So then now if you know the order of everything, can you just plug in your numbers? Okay. Last thing, double check your units before you plug them in. They always have to match R. So are you in liters? Are you in atmospheres? Are you going to be in moles? And are you in Kelvin? Okay. If you say yes to all of that, then you don't have to include units over here. So now we can just plug it in. So pressure is 1.2. Volume is 2.5. R is 0.0821. And T is 298. Okay. And then, does anyone have an answer for N yet?
8.5.
8.5. 0.12. Okay. Try 0.12. 0.12. Okay, and what's your unit for N? Just moles. Okay, so it comes 0.12 moles. Okay, this time we're going to figure out what volume will 2.0 moles of nitrogen occupy at 720 torr in 20 degrees Celsius. Okay, so what's your first step? Okay, so hold on. Focus up here. First step. We're just listing what's given. What's the first number given? Okay, and what letter represents moles? Okay, so N is 2.0. What's the next number given to you? Okay, 720 torr. Torr is a unit for, okay, pressure. What's that third number? Okay, so T is 20 Celsius. What is that in Kelvin? Okay. And then what are we solving for? Okay, and then finally, what other variable is always given to you for the ideal gas law that isn't going to be in a word problem? Okay, so R. Okay, so take a look up here. We have to look at units. So your units always come back to R. Volume we're going to solve for, so it'll be in liters. Pressures in atmospheres. Are we in atmospheres up here? Okay. No, so we're in the wrong unit. You with me? Okay, so what do we have to do? We have to convert it. Okay, it can't stay in torrs. If you look at the whiteboard, do you see my handwriting in purple up there? Okay, those are our conversions for pressure. So for every 1 atmosphere, there's 760 torr. Okay, can we use that to convert? Okay, can you do a little bit of like work off to the side? So we can do quick dimensional analysis. If you start with 720 torr, that means 760 has to go on the bottom. Okay. So you just divide. So what's 720 divided by 760?
Divided?
Yeah, 720 divided by 760. You're getting like 0.95. Okay. All right. Your new pressures in atmospheres. Okay, does that match R? So that one's good. Moles in Kelvin. Are your units matching right now?
Yeah.
Okay, so then you're ready to use the ideal gas law. Okay, what letter are you solving for? Okay, V. So how do you move P to the other side? Divide. So V equals nRT over P. Okay, now can we just plug in? What's N? Is it 2.0? Okay. R 0.0821, and then T 293, and then divide it by P, which is 0.95. Okay, so practice calculating. If you're typing it all in at once, you need to put parentheses around your entire numerator. Okay. Or can you just multiply, 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 get an answer, and then divide? You can do that too. So practice typing this in so you know how to use your calculator. Okay. Is that it? 50.6. Finally, sig figs. How many sig figs? 2. Or is there any number with less than 2 up there? Okay. So what should we round that to? Okay, and what's your unit? Okay. If you are unsure, you're going to go back to this R value. So what's your unit for volume in R? Okay, liters. Okay, last one. This time we're going to figure out what pressure will be exerted by 25 grams of carbon dioxide at a temp of 25 degrees Celsius and a volume of 750 milliliters. Okay, so what's that first number given? Okay, 25 grams of CO2. Out of all the equations we've learned so far, do any of them use grams? Okay, so what do you think you have to do with that number? Convert it to what? Okay, someone said it. Say it louder. Okay, moles. So if you're given grams, you have to convert it to moles. Okay. So how do we get from grams to moles?
Moles.
Okay, molar mass. Oxygen, 16, so it's 16 plus 16. 32. What's 32 plus 12? 44, and it's 12.01, so 44.01 grams is equal to 1 mole. Okay, so what's 25 divided by 44.01? What are you getting? 0.57. Okay. So moles is 0.57. What's the next number given to you? Hold it for volume. You have temp is 25 degrees Celsius. What is that in kelvins? Is that 298? Okay. What's the third number? Okay. What are you solving for? Okay, pressure. And then finally, what value is always given to you? 821. Okay, units. Units are super important. So before you move on, always check your units. Is volume in liters? Okay, no. Is that a problem? Okay. Who knows how many milliliters are in a liter? Okay, there's 1,000 milliliters in a liter, so we just have to divide by 1,000. Oops. Okay. All right, so volume is 0.750 liters. Okay. Is pressure? It'll be in atmospheres. N is in moles, temps in Kelvin. Do our units match? Okay, so once our units match, then we can use the ideal gas. Okay, so we'll use PV equals nRT. And what variable are we solving for this time? Okay, so how do you move v to the other side? Divide. All right, so pressure equals nRT over V. Okay, so everyone practice. Type in that equation. Can you get the correct answer? 5? Okay. 18.6. If you look at your numbers, which one has the least amount of sig figs? Okay, so 2. So what should you round this to? 19. And what's your unit? If you are not sure, you're always going to look at R. So what's your unit? Good. ATM. Oh gosh, that's a terrible M.